Okay, so this problem asks how much heat is needed to change 3 times 10 to the second grams of ice to steam at 130 degrees Celsius. So in a problem this long is when I think my chart comes in handy the most, because there's 5 different steps for this one, so it can kind of get confusing. So we're starting out at negative 30 degrees Celsius. Then we want to get to 0 degrees Celsius. Our ice is going to melt. Then we're going to need to heat it back up to 100 degrees Celsius. This is where it's vaporized. And then to get our final Q5, it's going to be heated back up to 130 degrees Celsius. So we have 5 steps to do. So we should convert our mass to kilograms. So that's just 0.3 kilograms. And our initial temperature we're starting out at is negative 30 degrees Celsius. And our final temperature is 100 degrees Celsius. So our first step, we need to heat up our ice. So Q1 is equal to mass times the specific heat times the temperature change. So this is just 0.30 kilograms times the specific heat of ice, 2060 joules per kilograms degrees Celsius, times our temperature change, 0 degrees Celsius minus negative 30 degrees Celsius. That's going to give us 0.85 times 10 to the 5th joules. Okay, so that gets us to 0 degrees Celsius, and now we're going to need to melt the ice. So Q2 is equal to mass times the heat of fusion. So that's just our mass, 0.3 kilograms, times our heat of fusion, which is 3.34, times 10 to the 5th joules per kilograms. That gives us 1.0 times 10 to the 5th joules. Then part 3, so for Q3, we're going to need to heat up our water now from 0 degrees Celsius to 100 degrees Celsius. So we use Q equals MC delta T again. So that's just 0.3 kilograms times now the specific heat of water, which is 4,180 joules per kilograms degrees Celsius. And our final temperature is going to be 100 degrees Celsius minus 0 degrees Celsius. That gives us 1.25 times 10 to the 5th joules. Now part 4, you can label that Q4. We need to vaporize and make it into steam. So that's just mass times the heat of vaporization. It's 0.3 kilograms times the heat of vaporization, which is 2.26 times 10 to the 6th joules per kilograms. That gives us 6.78 times 10 to the 5th joules. And our last step, now that we're at 100 degrees, we need to heat it up to 130 degrees Celsius. So our Q5 is equal to MC delta T. So we have our mass Now we're going to times it by the specific heat of steam, which is 2020 joules per kilograms degrees Celsius, times our T final, which is 130 degrees Celsius, minus T initial, which is 100 degrees Celsius, and we get 0.182 times 10 to the 5th joules. Now we have to find our total, so Q total is equal to all these added up, Q1 plus Q2, so on. And when you add those all up, we get our final answer of 9.40 times 10 to the 5th joules. That is how you solve this problem.